Stan Gibilisco here, episode number 9, or J9, of the complex number tutorial. At the end of a previous episode, I told you that if you ever encounter a quotient or a division problem with complex numbers that you should tremble with fear. Well, maybe not so much. If you have the book Pre-Calculus Know-It-All and you turn to page 96, you will see the derivation of a general formula for figuring this out. I'm going to go through that now and use the concept of the complex conjugate to make things a little easier. At first you'd think, how in the world are you going to approach something like that? How are you going to, you might say, well, it's A plus JB times 1 over C plus JD. Well, that's one way to look at it. Let's go with this one. No, let's not. Let's stick with the derivation in Pre-Calculus Know-It-All. Talk about an impromptu lecture. Well, that's the way it used to be in the olden days with professors in class, right? They didn't edit their videos as they went. They couldn't. They had to do it in real time, and that's the way I'm going to do it here. For better or worse, let's multiply this whole quantity here by 1. Well, 1 is anything over itself. So let's try C minus JD divided by itself. Well, what does this give us? In the numerator, it gives us A plus JB times C minus JD. And in the bottom, it gives us C plus JD multiplied by its conjugate. Well, if we'll remember the formula from the previous episode of this series, that's C squared plus D squared. Well, now we're making some progress here because C squared plus D squared is going to be a real number. We can multiply this out and then take advantage of the distributive property, and hopefully we'll be able to solve this problem that way. Well, let's see what happens. When we multiply A plus JB times C minus JD, we get AC. Got to be very careful with the signs here, plus a minus JAD plus JBC plus J times minus J. Well, I'm running out of room. J times minus J. That's a times sign there. Times B times D. I'll be very careful there. Okay, well now we've simplified this to this. But it's all divided by C squared plus D squared, remember. Well, we can simplify this part here to AC minus JAD plus JBC. J times the minus J is 1, remember? Because that's equal to minus the quantity J squared. So this is just BD. Well, we're just dealing with the numerator here now. I guess we should keep track of this denominator. So now we got this. Let's group the AC plus BD together, because that is going to be a real number. Put parentheses around it to isolate it from the J part. Now we've got JBC minus JAD. We can switch this around here and say it's plus the quantity JBC minus JAD. Again, all over C squared plus D squared. Well, now let's take it to the next level. This is kind of tedious, but I want to show you how we can derive a general formula for the ratio of two complex numbers. Then, once we've derived the formula, we can use it for anything. We've got it, we've done it in the general case, we can plug any numbers we want into it. We never have to go through this again. I'll bet that'll make you happy. AC plus plus BD plus J times BC minus AD. All divided by C squared plus D squared, but if you'll remember your distributive law, that's the formula. What we really can do now here is just take this J, move it here. We can get rid of these parentheses here. We don't need them anymore. We can get rid of these parentheses here. We don't need them anymore. I think I told you in another video, or maybe I didn't, about a professor that I had in college who practically had a fit when I used extra parentheses that weren't necessary. He was a mathematical purist. He would give people a B when all the other courses they took in the whole academic career were A's. And he was famous for that. And so people dreaded having this professor as their teacher for any of their classes. Well, I got him. They had one extra section that semester, and they had to find a professor to teach it, and he was the one. And when he wrote his name on the board, I thought to myself, I've been warned about this guy. I'm going to get an A from this guy, or know the reason why. And he gave me an A minus, sort of like this one right here. Anyhow, that's a little bit of an aside. We got rid of all these parentheses, and this is our general formula for the original ratio. And what was that? The original quotient, A plus JB divided by C plus JD. That's what it is. You can write that formula down, maybe get a tattoo on your arm with this formula. I wonder what would happen if somebody got a tattoo on their arm of a formula like this for a class, you know, where you had to memorize a bunch of formulas for a test. If you got a tattoo that had that formula on it, I wonder if that would be cheating. I mean, it would be part of your body, right? How can you cheat by just looking at a body part? Well, as you can see, I'm in fine form today. Only about 2 or maybe 3 people watch my videos anyway, so I'm not going to be known all over the whole world as a nutcase. I'm just going to be known by a very few select elites as a nutcase. Anyway, that is the formula, and you will find that general formula derived on page 96 and 97 of Pre-Calculus Know-It-All, which I wrote as the second book in the mathematics trilogy that I jokingly told my editor would change mathematics education in America. Well, I don't know about that. I know that the Asians seem to like this series pretty well, and that's good because I wrote it out of respect for the way the Asians learn stuff. So if you're from the Philippines or China or Japan, let me pitch my book to you. Stan Gibilisco, signing off.